The network types in OSPF. Network types. You see, when you connect a serial wire between two routers that runs OSPF, that has got a type. And when you connect a Ethernet wire between the routers that runs OSPF, that has got different type. And when you have different layer 2 protocols like frame relay, then it will have another type. So we have different OSPF network types. See, based on the network, based on the medium, based on the layer 2, layer 1 and layer 2, the network type also will vary. As I said, point to point is one of the network type. When you have a serial wire connected back to back, the layer 2 protocol is HDLC. When it is HDLC or PPP, point to point protocol, the network type will also be called as point to point network type. In OSPF, we have three types of network. One is connecting serial wire between two routers. And this is point to point. The other one is broadcast. If I connect a Ethernet wire, even though it looks like point to point, it is not point to point because the layer 2 protocol is not PPP or HDLC because the layer 2 protocol is Ethernet. OSP will consider this as a multi-access, a broadcast network, a LAN. Now, what is the difference? In this, there will be DR BDR election. Whereas in point to point, no DR, no BDR. That's the main difference. Point to point network type is by default when we have layer 2 encapsulation as PPP or HDLC. When you have Ethernet, then it is broadcast. It is broadcast. You may have one or more device like this. When you have Ethernet, definitely you can connect to a switch and you can have more neighbors. That's why by default in Ethernet there is going to be a DR/PDR election because when there is more than one neighbor, to prevent loop there is the need for DR/PDR. So point to point broadcast, these two are very commonly seen. In a LAN environment, you will see broadcast. When you type this command show IP OSPF, show IP OSPF interface, and the interface name if you put like Ethernet 0, it'll show you network type broadcast. Let me see whether I have any output. You see, this is the place. When you type show IP OSPF interface and interface name, it'll show you the network type as non-broadcast or point to point or broadcast and so on. Okay, so Whenever we have serial wire, it will be always point to point. Whatever the layer 2 encapsulation may be for point to point, it can be PPP, which is open standard, industry standard, and another one is HDLC. HDLC is seen only on serial wires, sorry, Cisco serial ports, because HDLC is Cisco's protocol. It's a Cisco protocol, HDLC. So whether it is Cisco or PPP, never mind, the network type is going to be point to point, and there will not be DRBDR, and they will have full adjacency. And the only multicast address used in point to point is 224.0.0.5. 6 will not be used in point to point. Why? Because there is no DRBDR, there is no need for 224.0.0.6. In point to point, it is only 224.0.0.5. Now, broadcast. When you have Ethernet, it is going to be broadcast network type. Fine. What is this non-broadcast multi-access? It is also called as NBMA. In this non-broadcast multi-access, again you have 5 different modes or types. See, the first type is point-to-point, second type is broadcast, the third type is non-broadcast. But in non-broadcast, you have multi-access with the 5 different variations, 5 modes. But overall, if you say there are 3 type of network types. One is point-to-point. What happened? One is point-to-point. That's it. Point-to-point is only if you have PPP and HLC. Broadcast is when you have Ethernet. It can be any Ethernet. It can be fast Ethernet or gig Ethernet or 10 gig Ethernet. Any Ethernet. And non-broadcast multi-access is, or non-broadcast is whenever you have frame relay. Instead of PPP, what do you have? Frame relay. ATM or X.25. If you have any one of this, then it is non-broadcast. See, in this also serial wire is what we use. But the encapsulation protocol is not PPP or HDLC. In this also we have serial port, not Ethernet port, not any special port. It is serial port, but we change that HDLC to frame relay or X.25 or ATM. If you will have any one of this as an encapsulation protocol, as a layer 2 protocol, OSPF will be considering it as network type non-broadcast. You may think like, whatever it considers, what is there for me? Definitely there is something. See, non-broadcast multi-access is over a frame relay. So definitely the neighborship, timer, all will not be same. Like you have DRBDR in broadcast, you don't have in point-to-point. See, that's a big variation. Likewise, you also have a very big variation with non-broadcast. And this chapter is about teaching those variations. When it is non-broadcast, how OSPF is going to behave. It's not going to behave the same way that it behaves in broadcast or a point-to-point. Okay, so in a point-to-point, it behaves differently than a broadcast or non-broadcast environment. All right. So, what are the 5 modes of OSPF operations that are available for NBMA network? The last line you see, 5 modes of OSPF operations available in NBMA. That is what I'm going to quickly show you. And these are the 5 modes. First two are industry standard, RFC standard. The last three are Cisco. So you cannot expect the Cisco thing in some other vendors. The first two are RFC. You will see on every vendor. But the last three, you don't see. So let us now go back and see the differences one by one. We have here 3 points, point to point, non-broadcast, and broadcast. Now, first one is point to point. As I said, if you have a serial interfaces and that runs PPP or HTLC, what is the default in Cisco router? Correct. If you have any one of this, then it is point to point. Now, this can also be a sub-interface. It need not be a frame relay sub-interface. It can be any sub-interface on serial interface. I don't know why they mix this frame relay thing here. Because in frame relay also you might have noted there is one point to point here. This point to point is different from that point to point. This is under NBMA point to point. Listen carefully. Under NBMA you have point to point. When you run frame relay only we call it as NBMA. But what we are seeing here is not frame relay. It is HTLC or PPP. But when you create, you may also be a point-to-point sub-interface running frame relay. So they're trying to point out that one which I showed you there, the fifth one. But that need not to do that. அதுக்குன்னு ஒரு தனி டாபிக் இருக்கும்போது எதுக்கு இங்க போட்டு குழப்பலான்னு தெரியல. பாயிண்ட் டு பாயிண்ட் கீழே பாயிண்ட் டு பாயிண்ட் மட்டும் பேசிட்டு போயிருக்கலாம். எனிவே அது உங்களுக்கு அந்த டிஃபரன்ஸ் தெரிஞ்சா போதும், உங்களுக்கு குழப்பம் வந்தா போதும். நெக்ஸ்ட், in this point to point there is no DR, no BDR. And you no need to say what type it is auto-detected. Depending on the interface encapsulation protocol type, it will automatically say, this is a point-to-point because he's running what? Serial HTLC. Serial HTLC. Auto-detected. Those things are auto-detected. OSPF packets are sent using this address. This is the only address that is used in point-to-point. Any question on this page? The second is broadcast network type, or you can also call it as multi-access broadcast because broadcast itself is multi-access. Generally, these are LAN technologies like Ethernet and token ring. In this, there is going to be DR and BDR. Don't worry about token ring. It is no more. No one uses token ring. That's another encapsulation type we had earlier days. In layer 2, we used to have token ring. Even on the switches, this token ring used to work. Even the switches used to work this token ring. Like we have Ethernet in VLAN and all, we used to have token ring. Okay. So generally, these are LAN technologies like Ethernet. In this, DR, BDR is needed. So there is going to be a BDR, DR, PDR election. Every other routers will form full adjacency with DR and PDR. But between the others, they will have only two-way relationship. And this also, you know, packet that are sent to DR and BDR is using 224006 multicast address. Packet from DR will be using 224005. Any question? As I said, election is there in a broadcast environment, broadcast type, network type. And how is the election conducted? First thing is it will give weightage to the router with a high priority. How do we configure priority? We go under the interface and say IP OSPF priority. Say, for example, if this interface is Ethernet 0, we say interface Ethernet 0, IP OSPF priority. That's all. Let's say 3. That's all. So this is per link. You should understand it is not per router. It's per link, per port. So before you bring up the OSPF, or before you say no shutdown on all this port, you have to configure this. Only then it will be according to the priority. What I'm trying to say is, after they form DR, BDR, don't go and try giving priority. So no use. Before the election starts, before these routers communicate, before they talk, before they communicate, before they try to form neighbor, you should have put these priorities. Because this DR-BDR is non-preemptive. Once a router becomes DR, it will remain DR until it goes down. Even if some router with the highest priority comes, it's of no use. Yeah, already elected. Non-preemptive. Yeah. So, hello packets are exchanged via IP multicast. What is the address? 5. Hello packets are sent using 5. The router with the highest OSPF priority is selected as a DR. The router with the second highest priority value is the BDR. See, if the priorities are tie, if all the routers are having same priority, only then it will compare the router ID. Only then it will compare the router ID. Use the OSPF router ID as a tiebreaker. Right. Next is the DR election is non-preemptive. As I said already, it is non-preemptive. Any question? Now, what if a priority is set as 0? By default, priority is 1 on Ethernet interface. Okay, I want to add something to the previous page. Here they forgot to say something. Here there is no DR-BDR election, right? That's why they did not say. The priority is by default 0 on all ports. The priority is by default 0 only. There is no use of increasing priority here because there is no DR-BDR, no? So don't waste time in configuring priority and doing some testing here. It is of no use. no use. Priority is no use. And the default is 0. Okay, so what is the role of the router with the priority 0? When the priority is 0, the router cannot participate in election. This will remain DR other always. It will never become DR or a BDR. If you want a router never to become a DR or BDR, why? Because that's a very old router and it is already slow. If it makes if you make it as a DR or BDR, it will have too much of responsibility, more CPU, and because of this, all other devices will become slower. So you don't want this router to become a DR or BDR always, and you need to put priority 0. This is the command to set priority. We need to go under the interface and say IPOSPF priority and then the number. As I said just now, you see the second last point. 0 means the router cannot be a DR or BDR. The router that is not a DR or BDR is called as DR other. The default priority is 1. You can set priority between 0 to 255. 255 is the highest. Different interface on the router may be assigned different values. So I said priorities per interface. Priorities per interface. This interface configuration command assigns the OSPF priority to the. Okay, fine. Any question on this page? All right, now we are getting into the third type. So far, how many we have finished? 2 types. One is point to point, another one is broadcast. In broadcast only we saw DRBDR. In broadcast only we saw 224.0.0.5 and 6. In broadcast only we learned about priority. Higher is more weightage, more chance of becoming DR. If there is tie in the priority, then it is based on the highest router ID. But if the priority is 0, that will never become a DR or BDR. In that case, it won't see the router ID. When the priority is 0, they remain DR other always. Now the third one is non-broadcast multi-access, and this has got 5 modes. All right, we are going to NBMA stands for non-broadcast, meaning that environment won't support broadcast. If broadcast is not supported, even multicast also won't be supported, which means there is only unicast support. Such network type are called as non-broadcast. For example, these 3 technologies that you see in the cloud, X.25, ATM, frame relay, these are all non-broadcast environment. Broadcasts are not supported in this. But what if I have single interface connected to multiple sites? Again, non-broadcast only, but with multiple access. We don't call it as again broadcast environment because it has got multiple sites. It is still non-broadcast, but with multiple sites, multi-access. That's what written in the second line you see. Non-broadcast topology supports multiple routers, but without broadcasting capabilities. Without broadcasting capabilities. DR election in non-broadcast topology. This is very important. See, in a non-broadcast, if you want this DRBDR, then you should have a full mesh connectivity. But full mesh connectivity is very rare to see in a frame relay or in ATM or X.25. Why it is very difficult? Because it is very costly. OSPF considers non-broadcast multi-axis to be like a broadcast media. So it will try to form a DR-BDR and DR other relationship. You see, I have multiple routers, multiple sites, and this is non-broadcast. Let's say this is becoming DR, and this is BDR, and these are DR other. DR other. What is the use of this selection? No use. If this goes down, there will not be any connectivity between these. Why? Because it is hub and spoke. It's not full mesh. In the real world, we will have only connection through this one. Everyone should go through the hub. They cannot directly talk. That is what called as hub and spoke. It's not full mesh. What is full mesh? Full mesh is this and this, 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 this and this. If you have connection like this, only then it is full mesh. But these lines are frame relay tunnels. 1, 2, 3. 3 tunnels, they won't buy. Why? They will say if A wants to talk to B, let him go to DR and talk. Let him go to C and talk. So they won't buy frame relay between these two. They don't buy. So they don't have full mesh. You understand? Yes, you understood or not fully? Really? Because we already have head office to, let's say this is head office and this branch office 1, branch office 2, branch office 3. Because these branch offices are already connected to head office through frame relay, again spending money on branch office to branch office, no one will do. So every time when branch office 1 want to talk to branch office 2, it will go to the head office and directed to branch office. That is how it is. So it is called as hub and spoke. In hub and spoke, if the DR dies, then you lose connectivity between the branch office, isn't it? The hub itself is dead. So what will happen? This will become DR, but what is the use? Now this will also become DR after some time. This will also become DR after some time. Why? They are not able to talk to anyone. They themselves will declare as DR, and it is totally waste. Yeah, they won't have any neighbor. All three become three individual. When the hub goes down, everything goes down. So there is no use of having a DR BDR. That's what's said here. The DR BDR needs full mesh connectivity, but NBMA networks are not not always, not always, not always. They're not always full meshed. They hub and spoke, as I showed you. The DR and BDR needs a list of neighbor, but the problem is when the hub goes down, there won't be neighbors. All right. And another thing is OSPF neighbors are not automatically discovered by the router. See, this point is very, very important. In a broadcast environment, hello packets are going to discover neighbor, isn't it? In a broadcast environment, hello packets are sent to discover neighbor. And the hello packets are sent to which address? 5. It's a multicast address. But what environment is this one? This is non-broadcast. In non-broadcast, multicast is also not supported. Multicasting is not supported. If multicasting is not supported, then no hello packets. If no hellos are sent, no automatic discovery happens. So neighbors need to be manually configured in this. In NBMA, neighbors need to be manually configured because it is NBMA, because it don't support multicasting. Not possible. Is there any question in this page? What do you learn from this page? In NBMA, there will be many routers because it is multi-access. Like a broadcast environment, it will try to have DR and BDR. These are the topologies you can see when you have NBMA. This is very rare to see because it is very costly. Usually what they do, they won't have this one. They won't have this line. They won't have this line. Only one, middle one, two, three. Only 3 lines it will be, like hub and spoke, like this. And there is hub and spoke, which is called a star topology, full mesh, and sometimes we will also have partially, this is full mesh, but with this it's not full mesh. It's called partial mesh. These are the topologies that we have in NBMA frame relay environment. So depending on the environment, we pick. We pick what? We pick the type. We have 5 types I told here. Depending on the environment, we pick. You got it? Right. So now